Hello viewers, in today's class we are going to discuss the continuity and differentiability of this given function, right? So here we are given a function f of x is equal to signum of x times sine x, right? And we have to see whether this function which is the product of signum function and sine function is continuous and differentiable at x is equal to 0, right? So what we will do in this lecture, we'll first see the continuity of this function at x is equal to 0, and then we'll see the differentiability of this function at x is equal to 0, right? So let us start. So now viewers, we know that for continuity of a function, what we do, we first find the left hand limit, then we find the right hand limit, and then we find the value of the function at the given point, right? So here the given point is 0, but for the general case we can take a point, say x is equal to a, right? So to prove the continuity of a function at some point x is equal to a belonging to the domain of the function, we find the left hand limit at this point, then right hand limit at this point, and the value of the function at the given point, right? And if we arrive at this result, that is the left hand limit is equal to right hand limit, and both these limits are equal to the value of the function at the given point, then we can safely claim that the function is continuous at that point, right? So here we'll one by one we'll take the left hand limit, then we'll take the right hand limit, and then we'll find the value of the function at this point x is equal to 0, right? So now let us first take the left hand limit, right? So the left hand limit, the notation for left hand limit is limit x tends to 0, and here we'll put a negative sign, and we have f of x, right? And now we can replace this function f of x by signum of x times the trigonometric function, that is sine x, right? And now here we'll take x is equal to 0 minus h, where h is a very small quantity and it lies between 0 and 1, right? So see, here we have x is equal to 0, and when we find the left hand limit, we are approaching from the left of x is equal to 0, right? So here in the neighborhood of x is equal to 0, we are taking the point 0 minus h, right, where h is a positive quantity and it is infinitesimally very small, right? So now this left hand limit is equal to limit h tends to 0, because see, when x tends to 0, then obviously h tends to 0, right? So now we can transform this limit in terms of h. So we have limit h tends to 0, and we have signum of, here for x we can write 0 minus h, and here we have sine of 0 minus h, right? Okay, now see, we have to evaluate this limit. Now here we cannot directly substitute the value of h is equal to 0 in this function, right? So what we will do, we'll here first quickly see the definition of signum function, right? See, signum of say x is equal to positive 1 whenever x is greater than 0, right? And signum of x is equal to 0 whenever x is 0, and signum of x takes the value minus 1 whenever x is less than 0. So this is the definition of signum function, right? And see, here we have signum of 0 minus h, right? So what is the value of signum of 0 minus h? So this is the important question here. So this is signum of minus h, right? So 0 minus h is minus h. Now see, we have just said that h is a positive quantity, right? This h is positive, so minus h must be negative, right? So it means inside this bracket we have now a negative quantity, right? So we have signum of some negative quantity, and for all negative quantities, see here x is less than 0. So whenever x is less than 0, then signum of x takes the value minus 1. So the value of signum of 0 minus h is minus 1, right? So now here we will write limit h tends to 0. Here we have minus 1, and sine of 0 minus h can be taken as minus of sine h, right? Because from trigonometry we know that sine of minus theta is minus sine theta. So here we have minus sine of h, right? And minus 1 times this negative sign, it becomes plus. So we are now left with limit h tends to 0 sine h, and this limit is simply sine of 0, and this is equal to 0, right? So the left hand limit of this function when x approaches to 0 from the left of x is equal to 0 is equal to 0, right? Now let us find out the right hand limit. So now for the right hand limit we have the notation that is limit x tends to 0 plus, right? So here we'll write the positive sign to signify that we are now calculating the right hand limit, right? And here we have f of x. Now see, in this case while calculating the right hand limit, we are approaching towards x equal to 0 from the right of x is equal to 0, right? So it means now we are in the neighborhood of x is equal to 0, but towards the right hand side of x is equal to 0, right? So this point is our 0 plus h, right? So now here we can write limit x tends to 0 plus. For f of x we can write signum of x, and here we have sine of x, right? Now we'll take x is equal to 0 plus h, and again h is a positive quantity, and it means it is greater than 0, and h lies between 0 and 1, right? So now here right hand limit can now be written as limit h tends to 0. So here we'll now change this limit in terms of h, because see, when x tends to 0, obviously h tends to 0, right? And now we have limit h tends to 0, and we have signum of x. For x we can write 0 plus h. Here we have 0 plus h, and here we have sine of 0 plus h, right? And again we'll give the same argument which we have given in case of left hand limit, right? See, signum of 0 plus h, right? And signum of 0 plus h is equal to signum of h, right? And see, h is a positive quantity, right? See, in that case h is a positive quantity, but minus h is a negative quantity. So here we have simply h, so it means we have signum of some positive quantity. And see, when x is greater than 0, then signum of x takes the value plus 1, right? So here signum of h, which is a positive quantity here h, we have signum of positive quantity as plus 1, right? And here we have sine of 0 plus h, so we can now write limit h tends to 0. Signum of 0 plus h is 1, so here we have plus 1, and here we have sine of h, so this is limit h tends to 0, and this is sine h, and if we take or if we tend h towards 0, we have sine of 0, and this is equal to 0, right? So the left hand limit was 0, and the right hand limit is also 0, right? So left hand limit is now equal to the right hand limit, and both the limits are equal to 0, right? And we claim that the limit x tends to 0 of this function, that is signum of x times sine of x, is equal to 0, right? So this function, the limit of this function when x approaches to 0, it exists, right? Now let us find out the value of f of a, right? So here a is 0, so f of 0 is equal to signum of 0 times sine of 0. Signum of 0, see here, when x is 0, signum of x is 0. So signum of 0 is 0 and sine of 0 is 0. So we have 0, right? So left hand limit is equal to right hand limit, and both these limits are equal to 0, and so is our f of 0, right? So the limits, both these limits are equal to the value of the function at x is equal to 0. So we can now claim that this function is continuous at x is equal to 0, right? Now viewers, let us now find out the differentiability of this function at x is equal to 0. So now let us check whether this function f of x, which is the product of signum function and sine function, is differentiable at x is equal to 0, right? So viewers, while checking the differentiability of any function at some point in its domain, what we do, we find the left hand derivative, then we find the right hand derivative, right? And we see whether these two derivatives exist or not, right? So if both the derivatives, that is left hand derivative and right hand derivative, both exist and they are finite and equal, then we can claim that the derivative, that is f prime of 0, it exists, right? So what we will do here, we'll first find the left hand derivative and then we'll find out the right hand derivative. So the left hand derivative, the definition of left hand derivative is given by a limit h tends to 0, and we have f of a minus h minus f of a divided by minus h, right? So always remember that this is the definition of left hand derivative, right? And the definition of right hand derivative is given by limit h tends to 0 f of a plus h minus f of a divided by h, right? And in this case here we have the positive h, right? So this is the definition of right hand derivative. Okay, so now here see, this point a is our x is equal to 0, right? So a is 0. So now the left hand derivative is the limit h tends to 0. We have f of 0 minus h minus f of 0, and here we have minus h, right? So for a we have substituted 0, right? So this is the limit h tends to 0. This is f of minus h minus f of 0 divided by minus h, right? Okay, now we have limit h tends to 0 f of minus h. Now from this function, if we replace x by minus h, what we will get? See, we'll have signum of minus h, then sine of minus h, and minus of f of 0, right? So while proving the function to be continuous, we have seen that the value of the function at x is equal to 0 was 0, right? So here we'll straight away we'll take 0, and here we have minus h, right? So now signum of minus h, we have just seen that this signum of minus h is equal to minus 1, right? We have seen all these quantities while proving this function to be a continuous function, right? So signum of minus h is minus 1, and sine of minus h is minus of sine h, right? And in the denominator we have minus h. So here these two minus get cancelled, or these two becomes plus, and here we are left with one negative, and here we can write negative limit h tends to 0, and we have sin h over h, right? And this is the well-known limit in calculus. So the value of this limit is 1, right? So the left hand derivative of this function at x is equal to 0 is minus 1, right? And here we have used the limit, that is limit theta tends to 0, sine theta over theta is always equal to 1, right? So now let us find out the right hand derivative, right? So here we have limit h tends to 0 and f of a plus h. So again we'll have a is equal to 0. So we have 0 plus h minus f of 0 divided by h, right? And this is limit h tends to 0, and this is f of h minus f of 0 is already 0, and we have here h. So we have limit h tends to 0 f of h divided by h, right? And now we can write limit h tends to 0. F of h can be obtained from here by taking x is equal to h. So we have signum of h, then we have sine of h, and divided by h, right? And while proving this function to be a continuous function, we have seen that signum of h was equal to plus 1, right? Because h is a positive quantity. So here we'll take positive 1. So we have limit h tends to 0. Here we have plus 1, and here we have sine h over h, right? So now this limit, that is limit h tends to 0 sine h over h, by virtue of this limit is equal to 1, right? So here we have got positive 1, right? So we see that this function f of x, which is the product of signum function and sine function, the left hand derivative is the minus 1 and the right hand derivative is plus 1, right? And these two derivatives are not equal to each other, right? So the left hand derivative is not equal to right hand derivative at x is equal to 0. Although the left hand derivative exists and it is finite, similarly the right hand derivative exists and it is finite, but both the derivatives are not equal to each other at x is equal to 0. So we can safely claim that this function is not differentiable at x is equal to 0, right? So viewers, this is how we can check the continuity and differentiability of functions.